Hi everyone, in this video I'm going to be talking about using square roots to solve equations. Now the type of equation we're going to solve with square roots is called quadratic equation. A quadratic equation is an equation where the largest exponent of x is 2. Okay, so here are some examples of quadratic equations. X squared equals 3 is a quadratic equation because it has the variable x has an exponent of 2. X squared equals 9x is a quadratic equation. It has this x squared term here. Okay? Now, the exponent of x over here is 1, but it's still quadratic because the largest exponent of x is 2. Okay? X squared plus 5x plus 6 equals 0 is a quadratic equation, once again because of this x squared. X plus 1 in parentheses squared is a quadratic equation. Now, some of you who are observant might say, well, the largest exponent I see on x is 1. But if we actually multiply this out, we expand x plus 1 squared, we'll see that this is really x squared plus 2x plus 1 equals 16. And there we have the x squared term that makes this equation a quadratic equation. Okay, so let's see some examples of how we're going to use square roots to solve quadratic equations. Okay, let's start off with a simple example. X squared equals 144. This is a quadratic equation because there's x squared here. In order to isolate x and solve for x, what I'm going to be doing is taking the square root of both sides. Okay, so I want to take the square root of x squared, and I want to take the square root of 144. Now, because I'm figuring out which values for x would make this true, I know that 144 has both a positive and a negative square root. Okay? So this plus and minus sign here that I'm going to write out in front of the radical tells me I'm going to take both the positive and negative square root. Okay, so let's write that down. Here we're going to take both positive and negative square roots. Okay, because both of those numbers will make the original equation true. Okay, the square root of x squared, okay, what number times itself gives us x squared? Well, that's just x. The square root of 144, well, the positive square root is 12. The negative square root is negative 12. So the solution to this equation, x squared equals 144, is x equals plus or minus 12. Okay. Now, let me point out something very important. Okay. This expression, this equation, that we've written down, x equals plus or minus 12, is actually shorthand for x equals 12 or x equals negative 12. Okay? So when I write this plus or minus in front of a number, I'm saying we should think of both the positive value and the negative value. Okay? And it's just a shorthand way of saying both. Okay? So instead of writing out this whole thing, I can just write plus or minus 12. Okay? Next example. Just like we saw with solving radical equations, it's important that we isolate the square. Okay? We're going to be using the square root sign, but before we do that, we first have to isolate the square. The square here is x squared. The 5 and the minus 100, those we have to move to the right side before we can take the square root. Okay? So I'm going to add 100 to both sides, and that will leave me with 5x squared on the left side and 100 on the right side. I'm going to divide by 5 on both sides, and that will leave me with x squared equals 20. Now I'll come over here, and I'll take the square root of both sides. So the square root of x squared equals positive or negative square root of 20. The square root of x squared is x. And now, okay, remember my radicals, I know that the square root of 20 can actually be simplified. I'm going to rewrite the square root of 20 as the square root of 4 times the square root of 5. So x could be positive or negative 2 root 5. Okay? So the values that would make the original equation true are positive 2 root 5 and negative 2 root 5. Okay? Let's see some different examples. Here I have x minus 3 squared equals 2. Okay, now let's remind ourselves that this would be a quadratic equation if we expanded everything out. Now in this case, we do have a square on one side and a value on the other side. Okay, so I want you to think of this entire expression x minus 3 squared as a square. And if we do that, we can think of taking the square root of this entire expression. Okay, so the square root of this whole thing. And that will be equal to positive or negative square root of 2. Okay? Now the square root of x minus 3 squared, what multiplied by itself will give me x minus 3? Well, what multiplied by itself will give me x minus 3 squared? Well, that's just going to be plain old x minus 3. You can think of the square root and this exponent canceling each other out. And that's equal to positive or negative root 2. I still want to get x by itself, so I'm going to move the 3 to the right side. I'm going to say x equals 3 plus or minus the square root of 2. Okay? Now since I can't combine the 3 and the root 2, because one's under a radical and one's not, I'm going to stop right there and say the solutions to the original equation are 3 plus root 2 and 3 minus root 2. Okay? Let me just write that out explicitly. Okay, when we write 3 plus or minus root 2, I mean x could be 3 plus root 2, or x could be 3 minus root 2. Okay, so either of these numbers, 3 plus root 2, 3 minus root 2, if I plug them into the original equation, would make the entire equation true. Okay, one final example. We have x squared minus 2x plus 1 equals 16. Now, with this equation, what I'm going to find is that I can't just move everything over to one side. Okay, let's see what would happen if that were the case. I'm going to do this in red so we know this is not what we should do. If I move negative 2x plus 1 onto the right side, what I get is x squared equals, let's see, minus 1, so 15 plus 2x. Then I'll take the square root of x squared and try to take positive or negative square root of 15 plus 2x, and suddenly I'm kind of stuck here. Because I'm going to get x on this side by itself, but I notice that there's still an x on the right side, and I don't really know how to take the square root of 15 plus 2x. Okay? So this method of solving this is incorrect. Okay? So let's erase this and let's talk about what the correct way to solve an equation like this is. I notice that on the left side here, I have a trinomial that can be factored. If I factor this left side, I get x minus 1 times x minus 1 equals 16. Well, x minus 1 times x minus 1, isn't that just x minus 1 squared? Equals 16. And now suddenly this looks a lot like example 3. I'm going to take the square root of both sides. So the square root of x minus 1 squared is equal to positive or negative square root of 16. Come up here. The square root of x minus 1 squared is just x minus 1. And the square root of 16 is 4. And I want both the positive and negative values of 4. To get x by itself, I'm going to add 1 to the right side. So x equals 1 plus or minus 4. Now, it's important to notice here that I can combine 1 and 4. Okay, I can add them together and I can subtract them together. And remember that we said that this expression means x equals 1 plus 4, and it also means x equals 1 minus 4. So knowing that, x could be 5, and x could be negative 3. Okay, so the solutions to x squared minus 2x plus 1 equals 16 are 5 and negative 3. Okay, I'm going to leave you with this problem to try on your own. X squared plus 24x plus 144 equals 8. The only hint I'll give you is that it's a lot like example 4. So if you need any help, go back and watch example 4. I'll even tell you what the solution is. The solution is going to come out to be x equals 12 plus or minus 2 root 2. So see if you can figure out the steps that go in the middle here to get us to a solution of x equals 12 plus or minus 2 root 2. Bring your work into class tomorrow and we'll discuss this problem as well as other equations we can solve using square roots. Alright, have a great night.